Hey everyone, and welcome. I'm Michael Steuer, CTO of the Casper Association. It's an exciting day for the Casper community and everyone watching the blockchain space and waiting for technology to connect with the real world finally. We're live today to mark the mainnet launch of Casper 2.0, the biggest protocol upgrade in our network's history. Today, I'm joined by Matt Schaffnit, our CEO, Ed Hastings, our head of engineering, and Joe Sacher, our head of SRE. Together, we'll walk you through what makes this release so transformative. And together, we will watch the upgrade take place live in real time. If you've been with us on this journey, you know that this has been a long road with challenges, breakthrough, and a lot of hard work. We've been building infrastructure not just for blockchain or crypto, but for the real world systems people use and rely on every day. And today, we finally get to show you what that actually looks like. So, first of all, thank you for joining us. We're glad you are here. We're going to walk you through what Casper 2.0 actually is. Not just a feature list, but we will share the philosophy behind the upgrade, the kinds of problems we're trying to solve, and why we believe this matters for builders, institutions, and anyone trying to bring real-world value on-chain. The first block on Casper 2.0 will be produced during this event, and we'll all celebrate the beginning of a new era, not just for Casper, but hopefully for the blockchain industry and the real-world systems we aim to transform. So why was Casper 2.0 needed in the first place? Let's start with the big picture. Matt, why is Casper 2.0 such a critical milestone for blockchain adoption?
Thank you, Michael. Appreciate the introduction, and I'm excited to share more with the Casper community at large. And please excuse my voice as my seasonal allergies have been acting up. To begin with, I think it's important to have a look at the origins from which the entire crypto industry comes, seeking to create an open, programmable, and trustworthy infrastructure layer for the world. Casper 2.0 marks a return to that idea, built with the assumption that real assets, real companies, with real people should be able to use blockchain without having to twist their workflows or relearn everything they know. This new chapter for the Casper network coincides with these ideals, an ecosystem built for builders, economies, institutions, and everyday people. We believe that Casper 2.0 answers that call, and that's why we're not focused on chasing trends. Instead, we're focused on building foundations. And to achieve that, this upgrade introduces 5 key features that are quite rare in the industry, providing the foundation for real-world utility. A new deterministic consensus protocol, ZOOG, that delivers instant finality because ownership and transaction certainty, especially in real-world systems, cannot be based on maybe or wait for 64 confirmations. It's role-based permissions, making it easier to model the way real-world systems assign responsibility and enforce trust. It's unlocking the functionality of the protocol's natively upgradable smart contracts, which can evolve safely and predictably with upgrades that preserve history without migrations. Additionally, it's offering multiple virtual machines, providing apps the ability to optimize over their diverse needs and use cases. Lastly, and maybe most importantly, Casper 2.0 meets developers where they are, offering familiar languages and production-friendly workflow that makes blockchain approachable for millions of developers across the globe. Together, these features form the foundation that is vastly more aligned with the real world and the way it operates.
Exactly. This isn't about hype. It's about usable, reliable infrastructure for people, businesses, and builders everywhere. So what does this all mean for and enable in the real world, Matt?
Absolutely. As the speculation wave recedes, the utility wave is accelerating. That's why we're focused on real world assets, where we're seeing the clearest demand for blockchain infrastructure that works like the systems people already trust. They're secure, auditable, upgradable, and adaptable. And we're seeing this across the board. Stablecoins are scaling, ETFs are normalizing crypto exposure, and major institutions from the DTCC to central banks are preparing for deeper blockchain integration. Casper has always welcomed developers and builders from beyond the crypto native world. With 2.0, we're delivering the tools they need: composable identity frameworks, on-chain workflows, and smart contracts that reflect the complexity of real-world systems. Let's take real estate. It's not just about ownership. It's about lenders, brokers, escrow, cosigners, regulators. With Casper 2.0, all of that can be encoded directly into the contract. You define who can do what and under what conditions. And as regulations or business models shift, the contract can evolve too, securely and transparency. Another example is IP. Artists and creators are stuck in a maze of middlemen. With Casper, you can embed the rights, revenue splits, and expiration logic directly to a license, so contributors can get paid fairly and instantly and automatically. What we're building is not a crypto experiment. It's infrastructure for the digital economy that works the way the real world already does, only slightly better with more trust.
Thank you very much, Matt. Super exciting. Let's dig into what's under the hood. Ed, our head of engineering, from your perspective, what are some of the most important technical capabilities in Casper 2.0?
And Zug consensus protocol. We're turning on in 2.0. So basically, the main advantage to it is that it's not probabilistic. When essentially consensus is reached about what the change to state will be, finality is immediate, and that's essentially advantageous, as mentioned in various real-world scenarios. The other deal is we've got the native access control and multi-sign, which are two different capabilities, but they can also be used together. And in combination, they give you role-based permissions, allowing developers to define access to entry points for their smart contracts. So our contracts can have multiple entry points. Each entry point can be restricted or not to 0 or more roles. We also have the multi-sign support. So transactions can be signed by multiple parties. So a co-owned asset that needs 2 out of 3 stakeholders, for instance, is doable natively. Similarly, if you have complex business or regulatory requirements where you need something like a person in a particular role to initiate and another person in another role to authorize, things like that. So these things all combine together to enforce that on chain. We also have the upgradable smart contracts, which we've had since Genesis. And then in 2.0, we continue to support that and have added additional features to make that, richer and more comprehensive. You don't have to do proxy contracts. You don't have to essentially try to manage your state migration off-chain and try to affect it all as part of an elaborate multi-transaction process. It just happens automatically. So basically, if you have, whether it's growth and functionality or bugs that you need to fix, you can do that with very little trouble or fanfare. And then basically, what we're aiming at is industry standard languages and tooling. So we use WebAssembly for our primary smart contract mechanisms as our execution environment. And then we primarily use Rust as the smart contracting language, but you can use any language that supports WASM if you prefer. And then we provide a lot of toolkits like the Casper product suite that give developers, end-to-end support, indexing, APIs, wallet interfaces. We also have things like Odra, which is a Rust-based framework for, modular TDD or test-driven development-oriented smart contracts. And finally, we also, in 2.0, we re-architected it to support multiple VMs. And so the goal is, as we go forward, to essentially have not one VM, but multiple different VMs that you can individually target when you send a transaction. That allows us to both evolve our WASM models, and as the state of the art continues to move on that, it also allows us to plug in process-specific or bespoke computation targets as well. The goal is to allow developers to choose the environment or tooling that suits their needs and essentially do computation on chain natively, not just locked into one particular flavor, right? So flexible and scalable, and orienting towards software infrastructure of real world applications as we go forward. Another sort of user-facing advantage that we've added in 2.0 is essentially we've allowed auction interactions to participate in the proof of stake. Previously, that required WASM to interact with. So if you wanted to stake or unstake and so forth, you had to send WASM to interact with the system auction. You don't have to do that anymore. It's essentially available natively. So you could just essentially send a standard transaction to do delegations and staking and so forth. We've also extended the system auction to allow contracts to stake. In 1x, only accounts could stake or delegate. So now in 2.0, contracts can also delegate, which opens the door for like liquid staking and things like that that people quite like. So essentially, it's just more, it's all the things it previously did, and then just more convenience and embracing more different scenarios. And that's the main focus there.
Thank you very much, Ed. Yes, it's a long list. I appreciate you hitting the highlights. There's a lot more detail available, obviously, on our website and in documentation. And we'll be highlighting some of these features and innovations, both individually and in some cases together, because I mean, you gave an example of upgradable smart contracts and the sort of access controls. And obviously, those are features that you could combine to implement the governance process around upgrading your smart contract, for example, right? So that's a case study or a use case that we could highlight as well. But yeah, these features really sort of show how Casper 2.0 models real-world systems. It has layered ownership, governance, compliance, and it's all natively enforced on-chain. Casper 2.0, as you mentioned, that doesn't force developers to relearn everything. We're giving them powerful tools, familiar languages, and well-designed frameworks across the board. Taking a quick look at the time, we expect the upgrades to activate around sort of 45 minutes after the hour. So we have about 7 minutes. I'm going to switch to Joe. Thank you for, there we go. Hey, Joe. And at some point during our chat here, Joe, we're going to see this Casper 2.0 upgrades happen in real time. But before we go into discussing some other topics, maybe you can give us a brief sort of overview or expectation of what we are about to see happen in the next few minutes, in the next 6 to 7 minutes.
Well, the upgrade is set up with an era activation point, so that will show us here. We can actually see the activation point here. What we'll actually get is a shutdown of nodes automatically, and you can see we're running 158. The actual executable will change to 2.0, start up, and then the network has to build 67% stake wait to go forward. So we'll wait as all of the nodes upgrade with slightly different timings, and then they'll come together, and then we'll see the first block. We'll get an immediate switch block, a locking in of that upgrade state, and then we'll switch to the new running era and go forward and start producing blocks.
Got it. So you're saying network goes down, your node goes down, you see it applying an upgrade, and then it comes back up, and then the expectation is that it's waiting to see 67% of stake come online in order to resume consensus, correct?
Correct. And then the proposer's block gets accepted and the network starts rolling forward and continuing
right.
on 2.0.
So the first sign of sort of all of us knowing that the network is back up and running is that first block being produced.
Correct.
Got it. Well, this is definitely an exciting moment in the network's evolution. We have some time to talk about some other things while we wait for this to happen. Joe, Casper 2.0 doesn't just pack improvements for users and developers, as highlighted by Ed and by Matt as well, but also for node operators. So while we wait for the network upgrade, can you highlight some of those features for us that make operating a node much more convenient with Casper 2.0?
Well, one of the big features, Ed actually touched on the direct calls to interfaces, which you'll see in the Casper client, where you don't have to remember endpoints and pieces because they're actually arguments in the REST client, which is really helpful for operation of your bid and lock-in. We've also implemented CEP90, which is a way that validators can set minimum and maximum stakes. So you can set a level above what the network sets for what a minimum should be. And those, your minimum that's higher than what the network says will be used, and your maximum that's lower than the highest network can be used. So you can kind of configure whether you want smaller stakers on your network or on your validator, I'm sorry, or larger stakers. And in addition to that, we've let validators configure some specific reserve slots. And that's useful if you have a different fee that you want to charge some people with a bespoke agreement for customers or guaranteed slots on your actual node. And so they can have a few delegator accounts that can come on to that. And the commercial terms you have with somebody could be different than what you just offer to the public based on other agreements. And some of the changes we've had prior to 2.0, I believe almost half of those were RPC changes. So the interface to the node. And so one thing we did with 2.0 is actually separate out the RPC interface to a sidecar process. And that's going to allow us to iterate on any interfaces to the node that people may want for future pieces without actually versioning and upgrading the network for it. And it also would allow people to fork that and do a specialized sidecar of a piece on there. It also limits the attack process for the node, right? If you have somebody beating on a separate process for RPC, that can go down and come back up without affecting the node, there. So that's a little bit of start of breaking pieces up into, pieces that can be upgraded separately, and it makes the architecture just cleaner. So that's something.
Yeah, you could even run your sidecar, your RPC interface on a separate separate machine, right? Basically.
Yep. And the actual link into the node itself is totally private. And then the sidecar has the ability to cache the events that come out of the stream, and you can query those separately. You could have custom processing inside it. And then with the new binary interface to the node, you can actually access that, directly for a little more performant integration, which will work with people once 2.0 is out there. So
we're getting pretty close here, right?
Yep.
We're about, I would say 60 to 90 seconds away. Is that what we're thinking?
Yeah, I think the last estimate was 45 after, and that's the block time. And so it's going to be a little bit past that. I'm actually watching on a different screen for the switch block to be made. So we see an era end piece.
Right.
And so the other piece for validators, there wasn't a really good metric for the performance of validators under highway. What we actually used for that is, here's the rewards we expected you to get. What did you do on that? Zug is looser in coupling while still participating, which is great. As you get a wider network and as you get faster, you're not going to be able to link up quite as tight. And so it's looking at your performance over 3 eras and three blocks. And so as long as you're providing signatures and finality within those pieces, you're considered participating. And as block time is sped up, you're not going to be able to sync exactly just because of the laws of physics and the distribution of nodes around the world. So that allows us to look at those elements. Have you provided finality within those pieces? And we can tell exactly how your node's performing in real time, rather than waiting to the end of an era to see, how many rewards, how well did you perform only every 2 hours. So that'll give us much better visibility into that.
Yeah, I'd like to dig into sort of the rewards a little bit more after we upgrade, because I think we're about to run out of time. But that's definitely a major improvement as well. I'm checking my own notes. If you see me looking around, I have a bunch of windows open as well. So it is 45 minutes after the hour now.
We should start seeing the switch block here shortly.
Yeah.
And what'll happen at the process of upgrade, we have 6% of stake or so that we can see that aren't staged.
Oh, I see a shutdown for upgrade on my screen. On my end, my node is upgrading, Joe.
Yep. I just saw mine.
Not the one we're sharing, though.
My validator here just started up on 2.0. And this,
Same here.
The validators shut down a little bit faster. They lead the charge so that the state is there.
Well, this is the moment we've all been waiting for and working towards. So
And so we're active right here. And what's happening now is it's parsing the block database. I've got about 1.5 million blocks on this one. So it'll take just a little bit to go through it.
What about the other one you have open, or are they in the same states?
Now this one's waiting to shut down. So there's a little bit more of a delay for a non-validator because they're following along with the network. So the validators will upgrade first.
So on my end, I see my node in state upgrading and reporting 43 pairs back at the moment.
Nice. So we've got a lot starting rapidly. Yeah, this one I was going to prune there we go. I was going to prune the database, but I wanted to wait till after the upgrade. So we're upgrading.
Right. So you can highlight that in the middle of the screen. It says reactor state upgrading.
I actually have 2.2 million blocks, it looks like. So this one's been going for a while. Uptime in this almost a little over 8 months. So now we're in validate mode. So now we actually see the last block is the switch block, the immediate switch block, it looks like.
So we're waiting for enough nodes to come online with version 2.0 to reach the 67% stake.
This one's finalized. We'll switch right into 17.890, which will be flowing in the first full era post upgrade. Yeah. When we have this immediate switch block, if we have to do any upgrades or change of the data, which on this upgrade, correct me if I'm wrong, Ed, I believe we pruned out any 0 bid records right at the point of upgrade. So we're doing some pieces to kind of clean up the data structure, and those will get applied and then locked in with this immediate switch block. So if there's any reason to go back and reference something, we can look at what was the state right after the upgrade. And that was added in, I believe, with our 1 to 5 fast sync pieces.
I'm at 85 pairs here, so are you. So we should be getting close to reaching consensus again.
And we're getting some validator thumbs up on in the validator chat. That's
you are able to multitask and look at more things better than I am.
I've got three screens. You got to look at a lot of servers when you're doing a lot of stuff. We should be at wait here shortly.
91 pairs.
Yep, slowly coming up. And this is highly dependent on, we recommend validators have TTL nodes, which are only having the minimal database.
Oh, I see. We went to 890.
There we go.
Are we live?
Yep, that's flowing.
We are flowing. We just upgraded the network to Casper 2.0.
And there's another block,
guys.
So we're rolling.
This is fantastic. Let me, I know we're not sharing it, but maybe take a quick look at Casper Live, which I'm sure others are doing as well. So maybe getting hit up quite nicely. It's also obviously upgrading and changing things sort of in real time.
The Casper Live nodes are full Genesis nodes, so they take a little.
So
longer
they might take a little longer.
Yeah,
that's probably what I'm seeing here. So I will move away from that. Well, congratulations, first of all, to the team here on this upgrade. This I know has been a long road, literally a couple years. We're talking about a major version upgrade that comprises. I think a few 100,000 lines of code changes, like 300,000-400,000 or something like that, and that is really just in the main sort of the main repository of the node. It doesn't even take into account all the different sort of tools around the node. So very, very major upgrades, and to see that happen in real time over the course of a few minutes must feel pretty good, Joe.
It's great. Ed and the team has done phenomenal on all the hard work getting this out there, and it's really nice to have a smooth upgrade. That always makes me smile. Most of ours, I don't know if we're still the only blockchain that can do synchronized automatic hard fork upgrades of a network, and we've done that from the start, and it just makes it very easy and for operators to stay in sync.
Yeah, and that sort of has proven throughout the process as we're working with obviously with the validator community, but more specifically with the exchange operators who all run, or not all, but many of them run their own nodes, as they do for many other networks. And the fact that we can provide these simple instructions and then it's basically sort of just a wait and see it happen or watch it happen approach is something that they're not used to as well. So that's definitely.
We hadn't shut down until after 45 after, and we were flowing before 50 after. So we were under 5 minutes in the process, which is great.
Um, while we're still looking at this, and obviously it's great, and I want to say we've obviously gone through 2.0 upgrades quite a few times in sort of trial runs, right, over the last months. I mean, we started with DevNet back in, I think, December, and IntegrationNet upgraded in January, TestNet in March. And we spin up ad hoc networks almost on a daily basis and go through upgrades, but really seeing it on mainnet, which is a unique environment with validators all over the world running on different hardware and different hosting environments, different latency, et cetera, et cetera. First of all, obviously that packs a lot of suspense for us, the team, because there can be surprises and unexpected sort of things that are hard to simulate outside of the real mainnet environment. But it's really nice to see that this went off the same way as we've seen it on sort of our test networks and without major surprises. So congratulations again to the team. So just before we move on from this, Joe, a quick question. What happens to once Casper Live is caught up and all the data there is sort of flowing again? What happens to the APY on the network while people are watching that? Because I know that for a lot of our watchers, that's an important topic.
Well, right at the upgrade point, you're going to see those who didn't stage are kind of in the set of validators, but they're not participating because they're kind of in a paused fork. So often we'll get some of those dropping out just after the upgrade. We work with them to get back going. So you may see a temporary boost in the network APY because the staking that's involved with their nodes goes down. So the rewards are always the same, but the staking percentage on how they're distributed will be there. We'll also see for validators, the rewards are going to be a little more stable and not based on what the other nodes are performing. Highway was a very tightly integrated system, which was great for locking up, but that's not necessarily good as you want to go fast. And so if one node was not performing well by design, there was a financial penalty to everybody. And Zug kind of decouples that, as we talked about. So you may see one node not performing well, but it should only take their rewards down now rather than kind of pulling it all down economically. And that's just by the consensus mechanism, in the definition.
Right. So the consensus mechanism now is based on sort of the provision of and the acceptance of finality signatures, right? So as long as your node is doing that in a timely and accurate fashion, that's what you'll see. And that once Casper Live switches over, that's also what the performance sort of number and little chart will indicate. But yeah, as you mentioned, go ahead.
Well, I was just going to say, in that something like Ed was talking about, the new architecture allowing us to plug in multiple VMs. While you can't have multiple consensus mechanisms at the same time, Highway is still available. And since the consensus is pluggable with Casper, we've actually run tests where we bounce every era between the two, and keep going on the network. So having good design and pluggability allows us to have much flexibility on this. We may have, a consensus mechanism that works better for blockchain, a few years down the road, and we plug it in the same way. So Casper is about being flexible and well designed to allow these changes to happen.
Absolutely. Fantastic. Thank you, Joe. So really appreciate you joining the call. And I know that it's probably you wanted to be like heads down and facing your monitor and watch this sort of in a different context, but appreciate you sharing this with our community and being here for this moment and celebrating it with us. So thanks you for that seamless upgrade process. It reflects years and years of engineering work, and it really lays a foundation for what comes next. Let's bring Matt back.
Hey, Mike.
Matt.
Hey,
Where do we go from here?
congratulations. Hey, first of all, huge success and a product of many years of hard work, but I'm especially proud and grateful to be working with the team of engineers and beyond within the group and cohort that we're working with here, because this was a big lift. And so big congratulations and thank you to them. So where do we go from here? With Casper 2.0 now live on mainnet, we're entering a new chapter, just like I said before, not only just for Casper, but also for the role blockchain plays in the broader economy. And that means continuing to support developers as they start building new real-world applications on top of the Casper network. Continuing to work with enterprises who need to secure, auditable infrastructure they can trust and explain, and continuing to expand the set of virtual machines, tools, and integrations that make this network more usable to more people over time. Casper 2.1 is already in motion, and with that, we'll begin to seeing more specialized execution environments and broader developer engagement. The next phase of growth will be community-led, ecosystem-led, partner-led, and we're excited to support that momentum to help shape what comes next, while also stepping back and letting builders build. So whether you're here as a developer, a validator, a startup, or just someone curious about where blockchain is heading, we're glad you're here, and this is your moment as much as it is ours.
Thank you. Yeah, absolutely. Casper 2.0 really is just the beginning. As you mentioned, Matt, Casper 2.1 is in motion. It will introduce an entirely new VM, more powerful contract development interfaces, and much more. And it's only a few months away. So super exciting.
Yeah, definitely. To everyone watching, developers, entrepreneurs, enterprises, this is your moment. Casper 2.0 is live. It's real world ready, and we can't wait to see what you build.
Thank you, everybody, for joining us. Please visit casper.network to explore more, dive into documentation, or connect with our team. And let's bring the real world on chain together. Thank you.